Okay, today our topic is relations and functions. Relations are mathematical situations where an input in an equation will have one or more outputs. The input is called the domain and the output is the range. If there is only one output for each input, we call this type of relation a function. We can graph relations and call the domain and range for each point on the graph an ordered pair. The first coordinate is the domain and the second is the range. So I am showing that here. Coordinates or ordered pairs, we put them in parentheses. Like I said, the left one is the domain, which is the x value, and the right one is the range, which is the y value. And the x value on a graph would go left to right, and the y value would go up or down. So I'll show that in just a few minutes. But let's talk a little more about a function. Okay, and again, a function is an equation where for each input value, which is your x, you only have one y value or output value. Okay, if you have more than one, then it's not a function. And with the graphs for these, you can do what's called the vertical line test. What that means is, so that's why I have this toothpick in my hand. You can see I have a series of graphs here. And we've got the horizontal axis, which that would be your x-axis, and the vertical axis, that would be your y-axis. And then the blue line is the line of the graph. So as I put a vertical line, which is my toothpick, over this line in the graph, everywhere I can position it, there is only one only one y value for every x value. So notice, for example, if this point here where my line crosses the line in the graph, if the coordinates for that were 1 for x, then you can see there's only one y value. Let's say it was 1, 1. That makes this style line graph a function, and we call that a linear graph, linear equation. Okay, now I put two different lines on this xy axis because of just saving space. So I put a horizontal line here, and notice as I do the vertical line test anywhere on that horizontal line, let's say that I position it right here. And let's say that that's about -1 on the x-axis and maybe 2 on the y-axis. Still, only one y value for that x value. However, look at this vertical line. When I put my line on top of it, when I put my straight toothpick on top of that, you can imagine if x were 0, not 0, excuse me, if x were, say, 2 right here on the graph, y would be many values all the way up the line, all the way down the line. I'd have positive y values, I'd have some negative y values. So bottom line is, we call a vertical line infinite many y values, and so therefore that would not be a function, okay, because you can only have one y value for the x value. Okay, well here's a curved graph, and you can see an upward curve. Everywhere I do the vertical line test, there's only one y value. However, so that one is a function. However, a sideways curve, you notice I can put my vertical toothpick line here, and let's say that right here on the x-axis, this would be x is 1. Well, you can see where x is 1, y would have a positive value and y would have a negative value. So this graph here is not a function. Okay, so that's important to be able to identify functions and those relations that are not functions. Okay, now our next topic is a linear equation. And that word linear means that the equation, when you graph it, it will form a line in the graph. Okay, so the graph of a linear equation is a line, and then linear equations in slope-intercept form is this equation, y equals mx plus b. We call that slope-intercept form. And we actually have more than one equation style that we can write for a line. I'm going to show you another one in a few minutes. But anyway, when we look at this linear equation, we want to consider the y-intercept. Now, what is that? That's where the line crosses the y-axis. So, if you want to find the y-intercept, the x-coordinate will be 0. So if you want to find it, plug in 0 for x into your equation, see how y comes out, and then the coordinates for that, or the ordered pair, will be your y-intercept. Now, if you want to find your x-intercept, where the line crosses the x-axis, then the way you're going to find it is put a 0 into the equation for y. And how x comes out will help you find the ordered pair for the x-intercept. Okay, so that's how you go about it. Put 0 in to the equation and find the other one, and then you can find the y and x intercepts. Okay, so how do you find the slope? And what is the slope? So in this equation, y equals mx plus b, the m here in the equation is the slope. Okay, so the m variable in the linear equation is the slope of the line. And we say the slope equals the vertical change over the horizontal change, or the rise over the run. And to find the vertical change and the horizontal change, we find what's called the difference in the values for two different ordered pairs on the line. So, find the difference of the y's and the difference of the x's. So I wrote down two different ordered pairs, and let's say we drew a line through these. This is our line we're dealing with. I'm going to call this one my first ordered pair, so this would be x1, y1, and I'm going to call this one my second. This would be x2, y2. But you can check it out. You could call this one the second one and this one the first one, and plug it into the formula, and either way you call it, you're going to get the same answer. So, okay, so here's the formula for the slope. M equals y2 minus y1 over x2 minus x1. So you're finding the difference. So my y values are 4 and 6. So I'm going to take 4 minus 6 divided by my x values, which is 2 and negative 3. So I'll take 2 minus negative 3. Now remember, when you see this double negative here, it means the opposite of negative 3. So the opposite would be plus 3. And you're going to add 2 and 3 and get 5. So here we have negative 2/5 as our slope for the line that these two coordinates come from. Okay? And so anyway, that's how you find your slope. Now, I did want to review how to graph things. Okay? What I've got here is a graph, and we call each section of the graph quadrants. And so what I've done is labeled the quadrants. This is your first quadrant, second, third, fourth. Now, why didn't they start counting over here left to right like we're used to? Well, there's a reason for it. This is the first quadrant because in the first quadrant, if you'll notice, your x values are positive, your y values are positive. This is the only quadrant where everything's positive. Okay, in the second quadrant, your x values are negative, your y values are positive. The third quadrant is where everything's negative. X values are negative, y values are negative. And then the fourth quadrant, we have our x values positive, but our y values negative. And the center here, where the y axes and the x axes cross, we call that the origin. So let's say that I want to plot this point here, 2 for x, 3 for y. Okay, I would start at 0, and I would count over 2 in the positive direction for x, and up 3, 1, 2, 3 for y. And quite often, people will label their points so that we know what the coordinates are right by it. Okay, now when we deal with negatives, I've got negative values here. I've got negative 3, so you go this way for x, 1, 2, 3, and then you go down for y, 1, 2, 3, 4, 5. So this would be negative 3, 5. Anyway, one memory technique is to envision a C and know that at the start of the C, that's quadrant 1, and then kind of right here is 2, 3, 4. Anyway, if that helps you. And there's even some little rhymes I've heard people make up for that C. But that can help you to remember where to start counting your quadrants. Thank you.